In this video, we are going to find molarity in two ways. This is the problem. A 26 milliliter of a 0.0154 m barium hydroxide solution was needed to neutralize 18.6 milliliter of an HCl solution. What's the molarity of the HCl solution? A 26 milliliter of a 0.0154 m barium hydroxide solution was needed to neutralize 18.6 milliliter of an HCl solution. What's the molarity of the HCl solution? This is the chemical equation. Barium hydroxide plus HCl, we get barium chloride plus H2O. This chemical equation is not balanced. First of all, we have to balance this chemical equation. Now you can see on the left hand side barium hydroxide plus 2HCl. On the right hand side barium chloride plus 2H2O. You can see on the left hand side 1 barium, on the right hand side 1 barium, on the left hand side 2 oxygens, on the right hand side 2 oxygens, on the left hand side 4 hydrogens, on the right hand side 4 hydrogens, on the left hand side 2 chlorines, and on the right hand side 2 chlorines. Ratio according to the balanced chemical equation, you can see the ratio to react with 1 mole of barium hydroxide, 2 moles of HCl are required. In the same way, to react with 2 moles of HCl, 1 mole of barium hydroxide is required. We know the molarity and volume of the barium hydroxide solution. Therefore, we can find the number of moles in barium hydroxide solution. Volume of this barium hydroxide solution is 26 milliliters. Molarity of this barium hydroxide is 0.0154 m. 0.0154 m. M is molarity, that means in 1 liter or 1000 milliliters of this barium hydroxide solution, there are 0.0154 moles of barium hydroxide. Now we need to find how many moles of barium hydroxide are there in 26 milliliters. We know in 1000 milliliters of this barium hydroxide solution, there are 0.0154 moles of barium hydroxide. Because this is 0.0154 m barium hydroxide solution. Therefore, in 1000 milliliters of this barium hydroxide solution, there are 0.0154 moles of barium hydroxide. Then 26 milliliters of this barium hydroxide solution, how many moles of barium hydroxide are there? We can find the answer in this way: 0.0154 mole barium hydroxide divided by 1000 milliliters barium hydroxide multiplied by 26 milliliters barium hydroxide. 0.154 mole barium hydroxide divided by 1000 milliliter barium hydroxide multiplied by 26 milliliter barium hydroxide. We should cancel out units. Milliliter barium hydroxide, milliliter barium hydroxide. Now we get 0.0004 moles of barium hydroxide. In 26 milliliters of this barium hydroxide solution, there are 0.0004 moles of barium hydroxide. Ratio 1 to 2. I have written that ratio here again. To react with 1 mole of barium hydroxide, 2 moles of HCl are required. To react with 1 mole of barium hydroxide, 2 moles of HCl are required. Now we have 0.0004 moles of barium hydroxide. Therefore, to react with 0.0004 moles of barium hydroxide, how many moles of HCl are required? We can find the answer in this way: 2 mole HCl divided by 1 mole barium hydroxide multiplied by 0.0004 moles of barium hydroxide. 2 mole HCl divided by 1 mole barium hydroxide multiplied by 0.0004 moles of barium hydroxide. We should cancel out units. Mole barium hydroxide, mole barium hydroxide. Then we get 0.0008 moles of HCl. In 18.6 milliliters of this HCl solution, there are 0.0008 moles of HCl. 0.0008 moles of HCl are in 18.6 milliliters of this HCl solution. Now we need to find the molarity of the HCl solution. We know in 18.6 milliliters of this HCl solution, there are 0.0008 moles of HCl. Then in 1000 milliliters of this HCl solution, how many moles of HCl are there? It is molarity. We can find the answer in this way: 0.0008 moles HCl divided by 18.6 milliliters HCl multiplied by 1000 milliliters HCl. 0.0008 moles HCl divided by 18.6 milliliter HCl multiplied by 1000 milliliters HCl. We should cancel out units. Milliliter HCl, milliliter HCl. Then we get the answer 0.043 m. Molarity of this HCl solution 0.043. Second method. There are two chemical solutions here. One is barium hydroxide, the other one is HCl. We can take this barium hydroxide solution as number 1 solution, and we can take this HCl solution as number 2 solution. There's no problem. If we want, we can take barium hydroxide solution as number 2 solution, HCl solution as number 1 solution. There's no problem there. Now we have taken barium hydroxide solution as number 1 solution. Therefore, we can take molarity of this barium hydroxide solution as M1, volume of this barium hydroxide solution as V1. We have taken HCl solution as number 2 solution. Therefore, we can take molarity of this HCl solution as M2, volume of this HCl solution as V2. M1, we know 0.0154. It has been given in the problem. V1, 26 milliliters. It has been given. M2, we don't know. We have to find it. V2, we know 18.6 milliliters. Now we can create an equation like this. M1 V1 equals M2 V2. On the left hand side and right hand side units are same. Now we can substitute these values to this equation. M1 0.0154 P1 26 milliliters equals M2, we don't know M2, we have to find it, V2 18.6 milliliters. I haven't mentioned units here. Ratio. But we must consider about the ratio. We know to react with 1 mole of barium hydroxide, 2 moles of HCl are required. Therefore, we should multiply barium hydroxide side by 2. Zero point 0.0154 times 26. Now we have to multiply this barium hydroxide side by 2. Because to react with 1 mole of barium hydroxide, 2 moles of HCl are required. Therefore, we have to multiply barium hydroxide side by 2. 0.0154 times 26 times 2 equals M2 times 18.6. We need to find M2, therefore we should isolate M2 on the right hand side of the equation. Then 18.6 goes to left hand side in this way. 0.0154 times 26 times 2 divided by 18.6 equals M2. Using your calculator, you can find the answer 0.043 M2. That means molarity. Quality of this HCl solution 0.043. Thank you very much for watching this video. Please subscribe our channel. God bless you.